Hello guys, what's up? This is Sir EJ and welcome again to another math tutorial. In today's topic, we will be discussing how to solve problems involving permutations. These are the following objectives we need to attain in today's topic. At the end of the lesson, the students should be able to letter A. Solve problems involving permutations. Letter B. Analyze each word problem to identify the given information. And letter C. Develop positive attitude towards work. We are already done discussing the different types of permutations in our previous lesson. Today, we will try to solve more problems involving permutations for you to be familiar on how to identify what kind of permutation the problem is. So let's have an example. Giants will conduct a beauty pageant entitled Search for Binibining Sipnayan. For this year, 10 students join on the said event. In how many ways can the third runner-up, second runner-up, first runner-up, and the title holder be selected? So the first step is to identify what kind of permutation this problem is. So to do that, let's identify the given first. We have n, the number of objects, which is equal to 10 because there are 10 students who will join on the said event. And we have the question in how many ways can third runner-up, second runner-up, first runner-up, and the title holder be selected. Meaning to say the value of r will be equal to 4. And if there is r, then this is an example of permutations of n objects taken r at a time. So we have 10 possible objects and we will just select 4 of those objects. So this one is an example of permutations of n objects taken r at a time. So we will use its formula. NPR is equal to n factorial over the quantity n minus r factorial. And then after that, we will substitute the corresponding value. So we have 10p4 is equal to the value of n is equal to 10 factorial over the quantity, the value of n is equal to 10 again, minus the value of r is equal to 4, then close parentheses followed by the factorial symbol. And then after that, we will simplify. So we have 10p4 equals 10 factorial is 10 times 9 times 8 up to 1 all over. Then minus 4 will be equal to 6. Then copy the factorial symbol. And then after that, we have 10p4 is equal to copy 10 times 9 times 8 up to 1 all over. So 6 factorial, we will expand it. So we have 6 times 5 times 4 times 3 times 2 times 1. And then after that, we will cancel out 6 times 5 times 4 times 3 times 2 times 1 on both numerator and denominator. And then we will bring down 10p4 equals, we have 10 times 9 times 8 times 7. Multiplying these numbers, the answer will be equal to 5040. Therefore, there are 5040 possible ways we can select the third runner-up, second runner-up, first runner-up, and the title holder if there are 10 students who will join the beauty pageant. Let's have our next problem. How many arrangements can be made from the word Tagaytay? So this one is an example of distinguishable permutations because there are objects or letters that are repeated. So we have to identify the given. The number of objects or the number of letters all in all is 8 letters. So we have 8 letters from the word Tagaytay. And then after that, letter T is repeated 2 times. So 1, 2, and then letter A is repeated 3 times. and then letter Y is repeated 2 times. After that, we will use the formula of distinguishable permutations, in which P is equal to n factorial over t factorial times a factorial times y factorial. And then we will substitute the corresponding value. P is equal to the value of n is equal to 8, then followed by the factorial symbol, all over value of t is equal to 2, followed by factorial. The value of a is equal to 3, followed by the factorial symbol, and the value of y is equal to 2, followed by the factorial symbol. And then after that, we will simplify. So we will bring down p equals 8 factorial is just 8 times 7 times 6 up to 1, all over 2 factorial, so we have 2 times 1. And then 3 factorial, we have 3 times 2 times 1. And then 2 factorial is 2 times 1. After that, we will just bring down p equals, we will multiply 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, or we will just press 8 on our calculator followed by the factorial symbol, and that is equal to 40,320, all over 2 times 1 times 3 times 2 times 1 times 2 times 1 will be equal to 24. So we just multiply all these numbers, and that is equal to 24. After that, we will divide these numbers. So 40,320 divided by 24 is equal to 1,680. Therefore, there are 1,680 possible arrangements we can make from the word Tagaytay. Let's have another problem. In how many ways can 5 different plants be planted in a circle? So this one obviously is an example of circular permutation because of the word circle. So we will identify the given. The number of objects will be equal to 5, the 5 different plants, and then we will use the formula of circular permutation, in which P is equal to the quantity of n minus 1 factorial. So we will just subtract n minus 1, which is 5 minus 1, and that will be equal to 4 factorial. And then P will be equal to 4 times 3 times 2 times 1. And then multiplying these numbers, the answer will be equal to 24. Therefore, there are 24 possible ways 5 different plants can be planted in a circle. For our next problem, a bracelet needs 10 chains of different colors. In how many ways can the chains be arranged or joined to form a bracelet? So this one is an example of permutations of objects taken all at a time, because we will select all the objects in the given. So we have the value of n is equal to 10, and we will select all these 10 objects to form a bracelet. So we will use the formula of permutations of object taken all at a time, in which P is equal to n factorial. We will just substitute the value of n, which is 10, and then 10 factorial will be equal to 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then multiplying these numbers, we have 3,628,800 possible ways 10 chains of different colors can be arranged to form a bracelet. Next problem. There are 4 copies of mathematics book, 5 copies of English book, and 3 copies of science book. In how many ways can they be arranged on a shelf? So this one is an example of distinguishable permutations, because there are objects that are being repeated. So the mathematics books is repeated 4 times because it has 4 copies. The English book is repeated 5 times because it has 5 copies. And the science book is repeated 3 times because it has 3 copies. So we will identify the given. The number of objects is equal to 12 because there are 12 books all in all. We have 4 plus 3 plus 5 is equal to 12. So n will be equal to 12. And then we have M is equal to 4. We have 4 copies of mathematics book. E is equal to 5 for the English book. And then S is equal to 3 copies of science book. We will use the formula for the distinguishable permutation. We have P is equal to n factorial over m factorial times e factorial times s factorial. We will substitute the corresponding value. So we have n is equal to 12 over m is equal to 4 followed by the factorial symbol. E is equal to 5 followed by the factorial symbol times s is equal to 3 followed by the factorial symbol. We have 12 factorial. We will expand it. 4 factorial, just expand the numbers. 5 factorial, expand. 3 factorial, expand the numbers. And then after that, we will just multiply these numbers. Or you can just press 12 on your calculator followed by the factorial symbol, then press equal sign. And that is equal to 479,001,600. And then multiplying these numbers, we have 4 times 3 times 2 times 1. This is equal to 24. 5 times 4 times 3 times 2 times 1. This is equal to 120. 3 times 2 times 1. This is equal to 6. So we have 24 times 120 times 6 is equal to 17,280. Then we will divide these numbers. 479,001,600 divided by 17,280 is equal to 27,720. Therefore, there are 27,720 possible ways we can arrange these books on a shelf. Let's have our next problem. How many 4-digit numbers can be formed from the digits 1, 3, 5, 6, 8, 9 if letter A, if repetition is allowed, letter B, if repetition is not allowed? So let's identify first the given. The number of objects is equal to 6 because there are 6 numbers. The numbers 1, 3, 5, 6, 8, and 9. And then after that, the value of R is equal to 4 because there are 4-digit numbers that we will form using these digits or numbers. So on our first question or condition, how many 4-digit numbers can be formed if repetition is allowed, meaning to say the numbers can be repeated. So on letter A, we will solve this using the fundamental counting principle. So on our first choice, we have 6 possible ways or 6 numbers we can choose from this digit or this position. Times, on the second one, on the second position, we have 6 again because the numbers can be repeated. Suppose we have selected here number 1. Number 1 can also be repeated here. So therefore, we have 6 possible selection here. And also, we have 6 here because the numbers can be repeated. 1, 3, 5, 6, 8, 9 can be repeated. And this one will also be equal to 6 because the numbers can be repeated. So the numbers can be 1,111. Those are the possible 4-digit numbers that can be formed using the digits 1, 3, 5, 6, 8, 9 if repetition is allowed. So by multiplying this number, 6 times 6 times 6 times 6 is equal to 1,296. So there are 1,296 possible ways of 4-digit numbers can be formed from the digits 1, 3, 5, 6, 8, and 9. How about if repetition is not allowed? So we are not allowed to repeat the numbers that is already been written. So in this case, since repetition is not allowed, this is an example of permutations of n objects taken R at a time. So we will use the formula NPR is equal to n factorial over the quantity n minus r factorial. And then we will substitute the value. So we have 6p4 is equal to the value of n, which is equal to 6, followed by the factorial symbol, all over open parentheses, the value of n is equal to 6, minus the value of r is equal to 4, close parentheses followed by the factorial symbol. Bring down 6p4 equals 6 factorial, we will expand 6 factorial all over 6 minus 4, this is 2, followed by the factorial symbol. So we have bring down 6p4 equals 6 times 5 times 4 times 3 times 2 times 1 all over 2 factorial is 2 times 1, and then we will cancel out 2 times 1 on both numerator and then the denominator. And then multiplying these numbers, 6 times 5 times 4 times 3 is equal to 360. Therefore, there are 360 possible ways a 4-digit numbers can be formed from the digits 1, 3, 5, 6, 8, 9 if repetition of the numbers is not allowed. For our next problem, there are 4 different math books and 5 different science books. How many ways can the books be arranged on a shelf if, letter A, there are no restriction? If there are no restrictions, we will just use the formula of permutations of n objects taken all at a time because there are no restrictions. Meaning to say, we will arrange all the books in all possible ways. So there are no restrictions. So the formula will be p is equal to n factorial. And the value of n will be equal to 9 because there are 4 math books and then 5 science books. So we will just add 4 plus 5, that is equal to 9. So n will be equal to 9. And 9 factorial will be 9 times 8 times 7 times 6 up to 1. Multiplying those numbers, we have 362,800 possible ways. How about if the books of the same subjects must be placed together? This time, there are restrictions we need to follow to solve the problem. Books of the same subjects must be placed together. So to do that, we will get the permutations of the math book. Okay, the permutation of the math book with no restriction, meaning to say the permutations of n objects taken all at a time. So we have the number of math books is equal to 4. So we have 4 factorial times, we will get the permutations of n object taken all at a time of the 5 different science books. So this will be equal to 5 factorial. So we will multiply these two permutations, the permutations of n objects of the math books and the permutations of the science books taken all at a time. And then we will multiply it by 2 factorial. So why 2 factorial? Because we have 2 subjects that we need to arrange, the math books and the science books, and they must be placed together, meaning to say the books in math are grouped together and the books of science is also grouped together. So the arrangement of that 2 groups is equal to 2 factorial. So we have 4 factorial times 5 factorial times 2 factorial. Multiplying these numbers, so 4 factorial is equal to 24, 5 factorial is equal to 120, then 2 factorial is equal to 2. So 24 times 120 times 2 is equal to 5,760 possible ways. Next, how about if they must be placed alternately? Meaning to say, if we will place science first, it must be followed by math. And then after math, it will be followed by science. So to do that, we will create 9 blanks and we will apply fundamental counting principle. Then on our first blank, this one is for the science books. On our first box, there are 5 different ways we can select science books because there are 5 science books. Times, on the second box, if this is for the science books, then on the second box, this must be for the math books. So there are 4 possible books we can select or we can place in this box. Times, if this is math, so we have science, math. So for this one, on our third box, this must be a science book. So if we have selected one science book here, then on this box, we have only 4 science books. Times, this one is for the math book, so this one is 4. So this one will be equal to 3 because we have selected one math book here. Times, This one will be equal to 3. This one is for the science books. This one will be equal to 2. This one will be equal to 2. And this one will be equal to 1. And this one will be equal to 1. So for the science books, we have 5 times 4 times 3 times 2 times 1. For the math books, we have 4 times 3 times 2 times 1. And we have placed it alternately. And then multiplying these numbers, there are 1,296 possible ways we can arrange 4 different math books and 5 different science books if they must be placed alternately. Let's have our last example. There are 12 people in a dinner gathering. In how many ways can the host, one of the 12, arrange his guests in the dining table? If letter A, they can sit on any of the chairs. So if they can sit on any of the chairs, meaning to say, this has no restrictions. And this problem is an example of circular permutation because it has a dining table. So we will use the formula of circular permutation. We have P is equal to the quantity n minus 1 factorial. We will substitute the value of n, which is equal to 12. 12 minus 1 will be equal to 11, and then 11 factorial is equal to 39,916,800 possible ways. Now, how about if 3 people insist on sitting beside each other? Now, to solve for that, we will subtract the value of n minus the 3 people insist on sitting beside each other. Then we will get its factorial. And then we will multiply it by 3 factorial. So this 3 factorial is the arrangement of those 3 people. Even though those 3 people sits beside each other, those 3 persons can also be arranged. So we will also get their arrangement, and that is equal to 3 factorial. And then after that, we will get the answer. So 12 minus 3 is equal to 9. 9 factorial times 3 factorial is equal to 2,177,280 possible ways. Next, how about if 2 people refuse to sit beside each other? So if 2 people refuse to sit beside each other, this one will be our solution. First, we will get the circular permutation of 12 people in a dinner gathering seated on a dining table. So this one, the quantity 12 minus 1 factorial. Then we will subtract it by 12 minus 2 factorial. So we will just repeat the process in step B. So we have 12 minus 2 factorial. So we have 2 people refuse to sit beside each other times, since these 2 people can also be arranged, so we will also get its permutation or arrangement, and that is 2 factorial. So this one will be our solution. Okay, the circular permutation, so we have the quantity 12 minus 1 factorial, and then we will subtract it by the quantity 12 minus 2 factorial times the 2 factorial, and then we will simplify it. So we have 12 minus 1 factorial is equal to 11 factorial. 11 factorial is equal to 39,916,800. So we have 12 minus 2 factorial is equal to 10 factorial. And then 10 factorial times 2 factorial is equal to 7,257,600. And then subtracting these numbers, 39,916,800 minus 7,257,600 is equal to 32,659,200 possible ways 12 people in a dinner gathering can be seated in a dining table if 2 people refuse to sit beside each other.